Hi, so far we've added an interactive circle where we can drag it around and move it around our canvas. In this video, we're going to make our game even more interactive by adding a slingshot to our game where we can drag back the ball from a starting position and launch it into our world. So let's get started. The first thing we need to do is know when we're picking up the ball. Right now, we can pick up the ball from anywhere. I can just move anywhere on the canvas, click, and the ball will jump there. But when we're working with a slingshot, we only want you to be able to select the ball if you drag starting from within the circle. So I'm going to go to sprite, and I'm going to add a method that checks if a point is within the sprite. So I can do def contains, which takes a point of type point, and is going to return a boolean. And I'm going to leave it up to the other sprite types to implement that. So for example, in circle, how do we check if a point contains is going to take a point of type point. Now, how do we check if this point is within our circle? Well, all we have to do is, this is going to return, we have to first check how far away from the center of the circle is this point. So I'm going to calculate the x_diff, which is going to be my location x minus the point x. And here is where we see the really nice thing about having this location be implemented in either circle or physics circle. Here now we don't need to have an alternate implementation of contains for a physics-based circle, because location will be overridden and that'll cause this implementation to stay correct even when you have a physics-based circle. So that's my x_diff. Now we have my y_diff, which is my y location and the point's y location. Now all I have to do is check that we use the Pythagorean theorem, and we're going to do x_diff times x_diff plus y_diff times y_diff, so a squared plus b squared. And this has to be less than or equal to my radius squared. So a squared plus b squared less than c squared. And that will tell us if this point, or actually we don't need to do radius squared because I'm doing the square root there. So we take the square root, so this gives us the distance from the center. And actually, since we might be calculating the distance from a point in the future, why don't we put this in point itself? So I'm going to actually move this out, and in point I can implement distance 2, which takes another point, let's call that, and now we can implement it here. So I can actually copy that entire x_diff y_diff thing. So here we have x_diff, which is going to be my x minus its x, and my y minus its y, and then this will give me the distance. Now in circle it becomes a lot easier to implement. I just do location dot distance to point has to be less than or equal to the radius. So now we've implemented it for circle. Now next we need to implement it for a line. With a line, it's kind of hard to tell what we want to return, if it's within the line or not. So I'm actually just going to go and say it's not on the line ever. So I'm just going to do contains, takes a point, and I'm just going to return false here because you don't know if you have a line, is that point on the line or really close to it. And lastly, we have box. Here we can implement it. Here we take contains, which takes a point of type point. What I'm going to do here is first I'm going to check that the x coordinate of the point is between the x bounds. So I check that first x is greater than or equal to the top left, which is location, the top left x coordinate, and I should do point.x. And I also have to check that point.x is less than or equal to the right side. So that's going to be location.x plus the width. And then I just need to do the same thing for y. So I'm just going to copy that. I'm going to do point.y is greater than or equal to location.y. Point.y is less than location.y plus height. So now we have checks on our x and y bounds. Now we're going to use this implementation of contains in on mouse down. So instead of directly setting dragging to true, I'm going to first do a check that the location has to be within our circle. So we have our ball dot contains, and we would like to just send in this mouse event, but we can't because we want a point. But here we're given a mouse event, so we can use implicit methods. So in Scala, you have implicit methods which allow you to provide a conversion between two types that can be implicitly performed, so then you don't have to specify that conversion. So here we're going to have an implicit conversion from a mouse event to a point, knowing our canvas here. So I'm going to define it within this method so that I have access to the canvas element so that we can do the offsetting. So I'm going to do implicit def event to point, which takes a mouse event, e, and we're going to return, and now we can just copy this, except instead of a vector, we're just going to use a point. So, and here point requires an integer, but we have a double here, so I'm just going to round it with 2int. And now we have an implicit conversion from an event to point. And you can see here now that this is compiling. So if ball contains e, only then will we set dragging to true. Now I can reload this, and now we can see that when I'm dragging around in the canvas here, nothing happens. But when I select the circle, I can drag, but here I can't drag. So now we have our check for when we can start drawing our slingshot. Now we need to actually make our slingshot happen. The first thing we need to define with our slingshot is where it's located. So I'm going to define a constant here, sling start, and this is going to be a point, and let's set it to 400 for now. Now we need to use this sling start when we're defining our circle, because our circle should start where the center of the sling is. So here I'm going to just pass in sling start for the initial position of our ball. So if we reload, we get our ball here. And our ball is actually pretty big for what we are looking for in our game, so I'm just going to reduce its radius to 20 pixels. So now we have a better sized ball so that when we have obstacles, it'll be able to fit in between the gaps. Now we have our ball set up. The next thing we want to do is be able to store the current position of the dragged ball if we're dragging a slingshot. So what I'm going to do is underneath the var dragging, I'm also going to do var sling end, and this is going to be an option of point. And we're going to initialize this to none. So the reason we're doing option here is initially, before you even drag the ball, there is no slingshot, but as soon as you start dragging the ball, you'll have a sling end, and we're going to continuously update the sling end as you drag the ball around. We're going to use sling end in two places. One, when we're actually dragging the ball around to update it, and two, we need to render our slingshot. So first, let's implement rendering the slingshot. So here what I'm going to do is I want to render the slingshot if sling end is defined, and with options, you can do that really easily by using Scala collection methods. So we can take this option and do for each. And the function that we pass to for each will be called if sling end is defined. So we can take our end, and then we want to render a line. So I'm actually just going to create a new line, which is a basic non-physical sprite here. It takes a start, which is going to be sling start, an end, which is our end, and a color, which is black here. And I'm going to render this with our canvas context. So here we're just quickly throwing up a new sprite and rendering it. Now if we reload here, we still don't have anything drawing because we're never even setting sling end. So let's do that. What I'm going to do is I'm going to define a method update sling end, which takes a new end of type point. So what I'm going to do is I'm going to take the new end of our slingshot, update our option to that, and also update the location of the ball, because when we drag back, the ball center should be the same as the end of the slingshot. So what I'm going to do is I'm going to sling end is going to equal to some new end. So now we set the sling end, and we're going to set our ball's position. So we're going to do ball body state pause is going to be new end. But this isn't going to compile because we have a point here, but we expect a physics.js vector. So just like we did here to convert an event to a point, let's implement a way to convert a point to a physics.js vector so that we can pass it to the physics engine. So I'm going to go in Sprite. Here we have defined a case class point. One of the places that the Scala compiler looks when it's looking for implicit conversions is in the companion object of the originating type. So here we have our originating type is point, and it's looking for an implicit conversion from point to vector. So it's going to look in the companion object of point. Now to define the companion object, I'm going to create an object point. And here I'm going to define the implicit conversion, which the Scala compiler will pick up. So I can do def point to vector takes a point, actually this should be implicit def, takes a point of type point, and we're going to return a vector. So let's create a new physics.js vector. Our x is going to be point.x, and our y is going to be point.y. So now we have an implicit conversion of point to vector, and we can see here that it compiled. And actually, we can use IntelliJ and say provide implicit conversion, and it actually shows us which implicit conversion it used. So now we have update sling end implemented. Now what we need to do is whenever our mouse dragging changes, the position of the mouse changes while we're dragging, we want to update the sling end. So the first time we need to do that is when we click. So we're going to do update sling end to our event, which is implicitly converted from a mouse event to a point, and then update sling end is going to implicitly convert that to a vector. So I'm going to do that, and I'm also going to do that here. So now we can actually get rid of this code and just do update sling end e. Now we can reload, and we can drag it around, and we have our slingshot. Now one thing we will notice is if we drag on the edge, our ball actually jumps to the center. We're not properly handling the diffs here, that we should actually say you dragged it not from the center, so keep that offset in mind. But for now, it's good enough. We'll probably come back to that issue later when our game is more mature. But that's it for this. In the next video, we'll look more into handling what happens when we let go of our slingshot. I'll see you then.